csir December 2019 B part question from real analysis. Okay. So here the question is, let gn of x is equal to n of nx divided by 1 plus n square x square for all x belongs to 0 infinity. Which of the following is true as n tends to infinity? First option, gn of x converges to 0 pointwise but not uniformly. Second option is gn of x converges to 0 uniformly. Third option is gn of x converges to x for all x belongs to 0 infinity. And fourth option is gn of x converges to x by 1 plus x square for all x belongs to 0 infinity. Now given gn of x is equal to nx divided by 1 plus n square x square. Now I want to find out limit. So what I will do is I'm dividing this both numerator and denominator by n square x square. We will get 1 by nx divided by 1 by nx n square x square, 1 by n square x square plus 1. As n tends to very large, this goes to as n tends to infinity, this goes to 0, this quantity goes to 0, and this quantity goes to 0, this is 1. So this goes to 0. Therefore, limit n tends to infinity gn of x is equal to 0, which implies gn of x converges to 0 for all x. So here the option number 3 is false because it converges to x. Here 4th is false. Now we want to check whether it is pointwise or uniform. So what is pointwise convergence? Pointwise. I will do pointwise convergence, and I will make you understand by using simple technique. Fn of x goes to converges f of x pointwise means, okay, for each x there exist an n, capital N belongs to n, that is capital N, which is a natural number, such that for every small n greater than this natural number, fn of x converges to f of x. That means fn of x mod fn of x minus f of x less than epsilon for any epsilon greater than 0, and for every x belongs to, and for every x. So here the main difference between pointwise and convergent uniform, here for each x we have to find out this capital N. That means as this n depends on x, then it is pointwise convergence. Now what is uniform convergence? So there is a difference. What is uniform convergence? Uniform convergence. Fn converges F uniformly if there exists a natural number n such that for every n greater than or equal to this n, mod fn of x minus f of x less than epsilon for all x, for all x. That means this, the difference is here there exists a particular n, that n satisfies for all x. That means if you get an n, then mod fn of x minus f of x less than epsilon for every epsilon greater than 0 and for every x. Then we say that the convergence is uniform. Now we will check what will happen here. Here we have and all uniformly convergent sequences point-wise convergence. So it is convergent to 0 point-wise. Okay, already it's convergent to 0 point-wise. Now if this converges to uniformly, then we can find this type of an n such that we can find an n such that this n doesn't depends upon x and gn of x converges to 0. So what is mod gn of x minus g of x is 0. This is mod nx divided by 1 plus n square x square minus 0. This less than epsilon. So I am taking any epsilon greater. So I am dividing by nx. So 1 by nx plus nx less than epsilon. So if I take reciprocal, then we know that x belongs to close to 0 infinity. So it's positive. Then we will get 1 by nx plus nx greater than 1 by epsilon. This implies nx greater than 1 by epsilon minus 1 by nx. As n tends to very large, this goes to 0, which implies there exists some n greater than or equal to small n. There exists a capital N such that small n greater than or equal to capital N, nx greater than 1 by epsilon, which implies n greater than 1 by epsilon into 1 by x. But this for n. But this n depends upon x. Therefore, answer is this is not point-wise convergent. So it is uniformly convergent. So second answer is correct. Now another method to solve this problem is by using theorem, but it takes a lot of time. So theorem, Fn converges F point uniformly if and only if supremum of mod Fn of x minus f of x goes to 0, converges to 0. So Fn converges to F uniformly if and only if this converges to 0 supreme. So in order to find out, we can use Gn of x is equal to nx divided by 1 plus n square x square. So in order to find the supremum, we have to find the extremal point. So for that, if we find gn dash of x and substitute to 0, we will get a value, and we will get 1 by x by computation. Then we will find g double dash of n of x. It will be g double dash of n of 1 by n. This is less than 0, therefore by computation we will get this. Therefore x equal to 1 by n is extremal point. Then we will check what will be mod gn of 1 by n minus 0. If this goes to 0, then it is uniformly convergent, but it doesn't goes to 0, and you can check this goes to 1 by 2. So this, in order to do this problem, it will take more than 15 minutes because this calculation is very large. But if we use this technique, the usual technique, this will be